Welcome to 4.5, graphing cosecant, secant, tangent, and cotangent. So first we're going to graph y equals cosecant of x. And again, we're going to kind of do the same thing that we did with your sine and your cosine. Cosecant, if you remember, let me change my pen width, is the reciprocal of sine. So we're actually going to graph your sine function first. Let me draw in my highlighter. Oops, that's an ugly highlighter color. Okay, so here's your x and your y axis. So when I go to graph my cosecant, I'm going to graph it as if I'm doing the sine first. So my pattern for sine is 0, 1, 0, -1, 0. Let me make those thicker. 0, 1, 0, -1, 0. And then I'm going to pretend like I'm doing my sine graph. I'm going to lightly draw in my sine graph. And I don't care if you write this in on your paper too. It might help you to do your function. Then we're talking about reciprocals. So if I flip a 0, I get an undefined. If I flip 0, I get undefined. And if I flip 0, I get undefined. So everywhere that I have a 0, which is here, here, and here, I'm going to put an asymptote for an undefined. And then, when I look at this, if I flip a 1, I get a 1. If I do the reciprocal of -1, I get -1. So I'm still going to keep these values here. And then all of these points here, okay, anything from 0 to 1 are things like a fourth, a half, an eighth, 3/4. When you flip those, they don't suddenly go down here and become negative. They're still positive. But if I flip a half, I'm going to get 2. If I flip 3/4, I'm going to get 4/3. If I flip 9/12, I'm going to get 12/9. So this whole entire part of my graph is going to flip up. And then same thing down here. All of these values are negative. They don't suddenly become positive. You're not going to go up here. These values here are going to flip down, and these flip down because you're finding the reciprocal. If I have a -1/2, for instance, and I flip it, I'm going to get 2. So all of these values are going to flip down to the bottom. And again, if you notice, you have one that's going up, one that's going down. If I keep going on my graph, we're going to get one up, one down, one up, one down. So it still takes 2 pi to get through one whole graph before it starts repeating your pattern up, down, up, down, up, down. It'll keep on going like that forever if you kept going. So it only takes you 2 pi in order to get to one end of your period. Next, we're going to look at secant. And again, let me make my highlighter. Okay, so if I want to graph my secant, that is the reciprocal of cosine. So I'm going to graph my cosine, which is 1, 0, -1, 0, 1. Still keeping in mind my 4 quadrants. And if I were to lightly draw in that graph, it looks like a bowl. And again, everywhere that I have a 0 at pi over 2 and at 3 pi over 2, when I flip a 0, I get an undefined. So I'm going to put in an asymptote. And same thing on the other one. All of these values here, oops, actually let me go back to these. If I flip a 1 or a -1, I'm still going to get +1, -1, +1. Those don't change. But this part of my graph, all of these values right here are going to flip up. All of these values over here as well are going to flip up. And all of these values in here, all of this are going to flip down. And again, if I keep going, obviously you only see part of this graph. You see one that's going down, And you see half of this one over here, half of this one over here. Well, if I continued, it would keep going like this if I kept going forever. And so it only takes me 2 pi to get through one period of my graph. And the reason I want to do this part is I want to keep you thinking about your unit circles 0 to 2 pi every time you do a graph. Okay, so now for tangent, okay, let's go back and remember on your unit circle, tangent 0, 0. At pi over 2, it's undefined, 0, undefined, 0. So I'm going to have, oops, let me draw on my highlighter. So you're just pretending that's a highlighter. So I have 0 for undefined. I'm going to put an asymptote, 0, undefined, 0. So my pattern for this one is 0, undefined, 0, undefined, 0. And then when we did when we did sine and cosine, you had points already to connect. There's nothing right here to connect. You can't just draw a straight line with these. So you're going to have to think of these as, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. And in the middle of every quadrant is a 45-degree angle. Okay? And the tangent at 45 is always 1. And then if you remember, our all students take calculus, in the first quadrant, tangent's positive. Second quadrant, tangent's negative. Third quadrant, tangent's positive. Fourth quadrant, tangent's negative. So in the middle of every quadrant at 45-degree angle, which since there's 6 lines here, in the middle of every quadrant, I'm either going to go up 1 or down 1. So in the middle of each of these quadrants, you're going up 1, down 1, up 1, down 1, in the middle of every quadrant. That way, when you have to do your stretch or your shrink, and in order to figure out what the pattern of your graph is, you have something to connect. And so here's part of my tangent. And if you'll notice, it's kind of hard to do with this because I don't have anything to do it. This part right here, in the first and second quadrant, if you notice, is exactly the same as in the third quadrant and the fourth quadrant. So really, when we graph 0 to 2 pi, we're graphing 2 periods. So the length of one period is pi, not 2 pi this time, like sine, cosine, secant, and cosecant were. So, but when we do everything, we're going to do it in terms of 2 periods. So 2 periods would be 2 pi. So you're basically going to have 2 graphs in the same amount of space that you had when you did cosecant, secant, sine, and cosine. And that is our general graph for tangent. Now cotangent, your tangent was 0, undefined, 0, undefined. That's tangent. So that means your cotangent is the opposite. So cotangent is undefined, I mean, it's not the opposite, sorry, it's reciprocal. So it's undefined 0, undefined 0, undefined. So we're going undefined, oops, let me draw in this first. So we're doing undefined, 0, undefined, 0, undefined. And again, so it's undefined, 0, undefined, 0, undefined. And again, in every quadrant, tangent is 1 in the first quadrant, tangent of 45 is -1 in the second quadrant, tangent of the 45 degrees that's in the third quadrant is 1, -1. So in the middle, you're still going to do the same pattern. Oops, +1, -1. Where's the eraser? Let's erase that. -1. So in the middle, you're going to do +1, -1, +1, -1. And this is my graph. And you'll notice once you graph this, just like the tangent, it only takes you pi to have the same graph before it repeats the pattern. So there's 2 graphs in 2 pi. So my normal period for tangent is pi. So 2 periods, which we're always going to graph 2 periods of tangent and cotangent, is 2 pi. That way, every time that we do anything, we're always doing 2 pi over b when we're trying to find the length of the graph that we're going to do. Okay, example 1, 3 cosecant x minus pi over 2 minus 1. So my amplitude is 3. My length of 1 period, there's a 1 in here, so 2 pi over 1, it stays at 2 pi. I'm going to go minus pi over 2, so it means I'm going right pi over 2. And I don't care whether you write right pi over 2 or pi over 2. If you write a minus, I'm going to mark it wrong because it means you're going to the left. And my vertical shift is down 1. So if you remember, just like everything else on sine and cosine, my phase shift is my beginning shift. I'm going to start at pi over 2. So if I start at pi over 2 and I add a length of 2 pi, that's going to take me to 5 pi over 2. I'm going to draw in. So I'm starting at pi over 2. 1, 2, 3. 5 pi over 2. If I average, 1 plus 5 is 6. 6 divided by 2 is 3. That's 3 pi over 2 in the middle, which means this one in the middle of 3 and 5 is 4. 4 pi over 2 is 2 pi. Halfway in between pi and 3 pi over 2 is 2 pi over 2, which is just pi. And then that means my x-axis is over here. So I'm going to highlight first. Trying to find a decent highlighter color. Okay. So we're going to mark my pi over 2 and down 1. And this is where I'm going to draw my graph from. And so let's do this in red. And so my normal pattern for cosecant is 0, oops, I forgot to put my endpoint. This is 5 pi over 2. Is 0, 1, 0, negative 1, 0. That's for sine. So we're going to multiply by 3. So we're going to do 0, 3, 0, negative 3, 0. 0, 1, 2, 3. Let me erase those. 0, 1, 2, 3, 0. Now normally this would be my sine graph. So I'm just going to kind of jot it in because it's going to help you keep track of everything. And then everywhere I have a 0, and you're going off of the new highlighted one, not the original. So here, here, and here, we're going to put an undefined. And then all of these points stay the same. And then all of this is going to flip up. All of this part down here is going to flip down. So this will flip up, this will flip down. And that is my graph for number 1.